So I think I'm probably the only one up here who's not actually a professional Erlang programmer, so I'm gonna speak more to the beginner experience of Erlang. I've been using it sort of as a, it's been my hobby language for the last sort of year and a half, 2 years. There we go. I'll listen for that echo. So last year and a half, 2 years. And it's been a great experience. It's been really cool. I've learned a ton of stuff. I've had a lot of fun. And I think I've really become a better programmer as a result. So so I just want to sort of talk a bit about that experience, like being new to Erlang and sort of what you learn by learning Erlang, and a few of the sort of aha moments I've had in the last couple of years, like the sort of, the things you have to sort of wrap your head around learning Erlang. And also talk a bit about how to sort of get started on, doing something that isn't, massive distributed enterprise grade robust systems. So, so learning a new programming language is kind of like going to a foreign country. It's if you're just there for a day trip, it's just all weird. It's a lot to take in, and it's just strange. But if you stick around, you get used to it, you find things that you really like, and when you come home, you sort of bring a little bit of that with you, or you find that you miss things. So, definitely in with Erlang, the syntax is a little strange, but you get used to that, and the whole sort of functional programming, working with closures and all of that, not having your for loops, that's all strange and weird at first. But yeah, you really learn a lot from it. So yeah, okay, so for example, my day job is writing Python. Python has some kind of functional aspects to it. I do a lot more list comprehensions now. I do a lot more with closures, and I think that's made my Python code a lot better. So one of the sort of breakthrough moments I had with Erlang early on was when we did the bowling game at one of the meetups, and I had done that a year before with actually in a Python group in a pair programming thing, and that was a it's a standard sort of programming thing. Figure out the score for a bowling game. It's the rules are just complicated enough that it's not entirely trivial. So and the end result of that was sort of 53 lines of code, if I remember right. And I felt pretty good about it. And then we did it in Erlang, and I think the end result that Rusty turned in was something around 10 lines of code. And that was kind of mind-blowing. And I looked at it and looked at what he'd done, and it was just solving the problem in a completely different way. And I went back and I looked at the Python code that I'd written, and I realized that there's, I'd done what you do in a no language. I'd start off, you model the problem. You have a game, you have frames, you add balls to the game, they get put into frames, but then you get into this whole sort of kind of metaphysical problem of like, well, okay, so is the frame just a dumb holder for data, or does it sort of know how to calculate its own score? Does it talk to other frames? Or does the game have all that logic? And you have all your usual sort of accessors, getters, setters, and that's all. You end up with a number of sort of a bunch of complexity that comes out of just the way that you've modeled it. And I realized that that's not necessary. You look at the Erlang solution, and you're not worrying about games and frames and all of that so much. You're saying, okay, my input is a list of roles, my output is a single score. Okay, that sounds like some sort of fold function. That's a very straightforward thing. Take a list, return a number. And the calculation's a little tricky, but that's sort of all it is. So so and I was able to go back into Python and sort of re-implement that. And you can do it roughly the same thing in about the same amount of code, but that's just not the way you would do it in Python, or at least not the way I would have at the time. So that's sort of bringing back some of that learning. It's just a different way of thinking about problems. Instead of starting with your model, you start with what's the data, what's the inputs, what's the outputs, where are you trying to get to? There's sort of a clarity and simplicity to that. So, and this is what the code ended up being. You can see this is really all it is to it. You start off with a score. You've got a list of roles coming in, and you call the frame function with your initial values, one frame, no score, and it's really just handling the logic of your conditions. You've got an end of game condition, you've got a strike condition spare, and normal roles, and that's really all it is. Each time you just handle that condition in the frame and move on to the next one. Take the first, in the case of a strike, just take the first roll, the rest of them you take the first and second rolls, and increment the frame counter, do whatever score calculations you need, and recurse. So, and you can see that the spare case is, it's really nice. It's very declarative, for the score when the first and second add up to 10, and that's exactly what the rule is. So, you end up with this really, sort of almost like a mathematical proof of bowling. Coming back to earth with that, I've ended up this year writing a bunch of client-side JavaScript code and CoffeeScript code, doing rich browser clients. And that's all very event-driven programming. It's all widgets and callbacks. You end up doing lots of closures in CoffeeScript. It's defining all the behaviors and callbacks for your functions. And so, I was really glad that I'd had the experience with Erlang going into that, had some functional programming experience. And and so that made that whole thing sort of nicer. I had this model of like, oh, okay, this is how you do it. And JavaScript has odd sort of OO bits in it, prototypal bits, and it's easy to sort of muddle those up and try and program JavaScript like it's an OO language, and it's really just not. It actually works a lot better if you treat it as a functional language. And so the other thing about the whole Erlang newbie experience is that this is an awesome community. I mean, it's still actually relatively small, and you can go hang out on your Erlang questions list and sort of just kind of lurk there, and you see you see everyone posting. You see all the core developers, and you see Joe Armstrong posting stuff, and you see that Loke and the people who build all these frameworks. And it's a neat mix of sort of theoretical computer science stuff and practical, like how do you build this stuff at scale. So so that's been a great learning experience. So some of the things that you need to sort of, or some of the kind of aha moments I've had working in Erlang. So the first thing that people tend to get kind of hung up on is syntax. It's the least interesting bit of weirdness in Erlang, but the thing that really helped me make sense of this is realizing that no, it doesn't look like C. It does look kind of like English. I mean, you have a function it expresses a complete idea. It ends with a period. You have clauses that end with semicolons. You have lists of things that you do in between that end with commas. And module declarations and definitions and all of that. That's a complete idea. It ends with a period. And all the little case statements or case blocks inside. First of all, remembering that case and if and receive and all of those are not command structures. They're functions. They return values, and that they have their own sort of little mini function with clauses in there. But anyway, so that's essentially just like a little cheat sheet. Maybe to have in the slides or for reference. The second thing is understanding recursion. Okay, I come from a Java, Python, OO background. You never use recursion. Really not if you can help it. Sometimes you have something that really requires it, and then you put a whole lot of warning signs around it, and you try not to mess with that code. Because you've got global state, and you can have all sorts of weird side effects with that. And so since people don't work with it, they don't get familiar with recursion, and it remains this poorly understood thing and kind of scary. Erlang uses it for everything. You don't have for loops, you recurse. You don't have any of your normal looping structures. It's all recursion. And this is where the bits of Erlang where we're going to start working together. Like the immutable variables make it really easy to deal with recursion because you know that nothing else is going to change outside of this little handling loop you're doing. In a particular instance of or particular function clause, you don't have to worry about global state. Everything's a constant as far as you're concerned. So the other thing is that writing recursion all the time, you develop sort of patterns for doing this. There are idioms, and really there's only a handful of them. So to sort of lay out the simplest of them, it's like a story. You've got a beginning, a middle, and an end. The easy bits are the beginning and the end. So I'll start with those. Generally, in the beginning, you've got an input, and really you just set up your output accumulators, whatever that's a list, maybe it's just a number. And then you recurse to the function with two parameters. The end is also really easy. Basically, you run out of input, and you return your results, whether that's just a number, it's a list, reverse list, whatever you've been building in between. The middle is really just getting from n to n+1. And it's, in this case, you just pop the first thing off your input list, you lunge it, you prepend it onto your output list. And in fact, that's simple enough that basically the Erlang lists library kind of encapsulates that for you. You can do a map function that just takes your function and maps it to values, maps one list of values to another list of values. So, and essentially all recursions are of that type. They're sometimes tail recursive, sometimes not, but that's the basic idea. You've got a start, you've got an end, and you've got your middle loop of n to n+1. So the next thing is processes, like understanding processes, because that's another thing that normally in OO languages you try to avoid. You don't want to do threading in Java if you can avoid it. It's painful, you have to synchronize all over the place, it sucks. In Erlang, of course, you use processes for absolutely everything. And the interesting thing about this is it kind of makes Erlang more object-oriented than object-oriented languages, right? Because the original idea is that objects are these little sort of intelligent agents that send messages back and forth and they coordinate to do work. In practice, in OO languages, they're really just, they're dumb blocks of data with functions attached. Or at very least, they're essentially just, they're passive. It's a defined thing, but it's just waiting for a thread of execution to come along and do something to it. And you get all sorts of problems when you have two threads of execution working on the same object at the same time. In Erlang, you sort of reverse that or sort of turn it inside out in that all of your data is just owned, or any piece of data is owned by a process. And it's only accessible to that process, and any access to it is controlled by that process. So you actually have these little sort of living things in your code that are sending messages back and forth and modifying the data. And how that's done is actually really simple, and it's actually easier to show than to try and explain. So typically you just have a message handling loop that, I mean, that's not actually what you would write, but that's effectively what it's doing, right? You've got an incoming state, you're receiving a message, you're doing something with that message and generating a new state, possibly the same as the old state, and then you're looping again. And you just recurse with the new state. So to come up with a really just dumb, simple example of this is just an auto-incrementing counter. If you want to have like a little object that's just my auto-incrementing ID, that's kind of all you need. You've got a loop, you've got the old ID coming in. Whenever you receive a message, you increment the ID, send it back to the requesting kid, and then loop with the new ID. It's, everything else is elaboration on that. And the way you kick that off is also pretty simple. You've got, you just spawn off that process. You can do that with a local definition, or you could do the sort of module name, function name arguments. But essentially, you just spawn that process, and then you can send that PID message with your own ID. Self is the current process's ID, and the the message body is just next. Give me the next thing, and you wait for the response to come back, and that's it. This ID you received. So, and when I say Erlang uses processes for everything, I hadn't realized quite how true that was until I opened a file, in the Erlang shell, and what comes back is a process ID. It's not a file handle like you would get in C or something. It's not a pointer to memory. It's the process that you're going to talk to do whatever operations on the file, to read or write to it. That file is owned by a process. So even at that kind of basic level, even when you're dealing with just a file, something that basic, it's still wrapped in a process. And of course, there are also Erlang libraries to make this all easier. The Gen server, Gen event, those handle a lot of the communications infrastructure and let you focus on writing your business logic. What is the server going to do? How does it respond to events? How do you same with Gen event, which is more sort of multicast. The point is that there are libraries and tools and frameworks to help with this that standardize these idioms. So how do you get like a little? How do you get practical experience with this, short of getting hired to build something huge and scary? You can do scripting. Erlang's got eScript. It lets you do shell scripts the way you would do Python or Ruby or whatever. You can just write Erlang, run it from shell, and it's this easy. You declare a main function. You've got your arguments coming in. You do whatever you want. You can also use that little special comment line to send messages or to pass parameters to the Erlang shell. And so you can specify name or sname, and then your shell script becomes a node, becomes an Erlang node, and it can talk to other Erlang nodes and do whatever you want any other Erlang node to do. Anything you do from the Erlang interpreter, you can do with this. You can automate things, whatever you want. So you get all the power of the Erlang libraries, plus you can talk to Erlang nodes, and it's all within a shell script essentially. So one simple example of this is just using the iNuts and HTTP client libraries to just fetch a URL. And this is actually kind of cool because it demonstrates what you can do in Erlang with unpacking parameters here, unpacking response structures. So your HTTP request, fetches URL, and it returns a block with the the status, which is like the HTTP protocol, the HTTP response code and its description, and then all the HTTP header block, which is a list of things which I don't care about here, and then the actual content that's coming back. And you can just, one line, break it all out. And do I have an example of that? Yes. So that actually turned out to be really handy. I was doing building a little REST service, and I wanted something to test it with. That was awesome. It was, you just have to hit a URL, check the response, make sure it's what you expect it to be. So I was able to write this little testing thing in Erlang. And if you wanted to load test it, you could fire up a whole bunch of processes and pound the crap out of it. So yeah, that's one side of testing. The other thing that I got to do this year, actually getting to write Erlang for work, all of about 50 lines, was writing up a mock REST service. So I had a rich JavaScript client that was going to talk to a backend, and the backend was running on an embedded system that I didn't have access to. So I just mocked it up in Erlang, and it was an easy 50 lines to write. I don't think I have the example of it here, but it was something along these lines. So I used the Spooky framework, and there are any number of things, alternatives, but that's the one I was familiar with. And defining a mock web service is just a whole bunch of get methods. And you can see from the URL there, the way it breaks up the path, it just, path to resource gets broken up into a list of strings. And you can match on those, you can do the exact match, or you can match with unassigned parameters. So just pull that out. So that was a super nice and easy way to do that. If you're coming from a web background, there's a ton of little, just building web application stuff that you can do with Erlang. There are a bunch of frameworks. You saw Cowboy. These are the ones I'm familiar with. Spooky is good. It's like, Spooky is sort of like Ruby's Sinatra. It's a very, very simple but very basic. If you want to do something more complicated, Chicago Boss looks pretty neat. That's more of like a Django/Pylon style framework. It's got templates, it's got URL routing, it's actually got a, what he calls an object relational mapper. I mean, it's sort of, not really objects, but it's, property lists. But, it makes it look like, if you're coming from a Django background, this will all be familiar. It's sort of like, the gateway drug for Erlang. It makes it really easy to learn. Web Machine, I haven't done much with it. That's another Basho product, thanks to you folks. If you really want to get into the richness of the HTTP protocol, and see what actually happens at all the stages of handling, and the resource the negotiation that goes on over the formats and all of that, content type. You can all of those levers are exposed. You can dig in and work that to your heart's content. Not the easiest thing if you're new to that, but it's definitely an education. So you can also contribute to a lot of these projects. A lot of these are new. There are features that need to be made. If nothing else, documentation. Write another tutorial. Take advantage of being a beginner and sort of come at it with that fresh view. The people who wrote the tool know it inside and out. So if you write the how do I learn this thing starting from zero, that's super helpful. And in some cases, they're actually not bugs, they're opportunities to contribute. You'll find little things where it's like, oh wait, I'm doing this weird edge casey kind of thing, and I broke something. And it'd be awesome if all of our software worked perfectly all the time. Next best thing is the source is up on GitHub, and you can fork it, fix it, put in a pull request. And that's also just digging around in some of the code, even if the project is working perfectly well. Digging around in the source code is a good way to learn. good to see how other people program Erlang. And yeah, I can say I've learned an awful lot having to get up here and do talks. Like I said, write tutorials, figure out how something works. Figuring out how to explain to somebody else how it works really forces you to learn it a whole lot better. So that's it. As an Erlang beginner, adventure awaits you. There's all sorts of cool stuff to do. And a lot of stuff is going to be, a lot of what you learn will be useful outside of Erlang. There's a lot of, Erlang's a good introduction to a lot of these functional programming things that are showing up now in, in the JavaScript frameworks, in languages like Scala and Clojure. That's getting to be a big thing now. And I actually found Erlang to be a much nicer introduction to that than going straight to Lisp. It just feels nicer in some ways. So that's it. That's me. All this presentation's up on GitHub, as you can see. GitHub Pages is awesome. That's my slideshow is awesome. And that's it.